Welcome. Good afternoon, everybody. Hope you're enjoying the second day of the DevOps Con here in Munich. I sure am. My name is Michiel Rook. I'm a independent consultant from the Netherlands. I'm a CI/CD coach, a DevOps coach, and based on the experiences I gathered in that role, I developed this talk. Somebody asked me over there if that's my dog. It's not. I do have a dog, but I don't have a picture of my dog hanging out of the window like that. Reason I chose this picture is because I think this talk, while it could be considered starting out as a little bit negative, we end up on a very positive note. And being able to deploy on Fridays, that's where we're going to end up. Made me feel, like a dog feels when they put their head out of the window. The sheer joy that you see on a dog's face when they put their head out of the window on a moving car, that's just very good to me. Anyway, if you want to reach out to me, that's my Twitter handle. My DMs are open if you want to reach out to me during the talk or after. If you have complaints or suggestions, anything goes. Let's get going. This talk, even though today is a Wednesday, this talk is about deploying on a Friday. And depending on the company and the people in the company that I talk to, there may be two different reactions. And the reaction I see the most, still to this day, is deploying on a Friday. Are you seriously out of your mind? I'm thinking, let's start again. There we go. These are the memes that you associate, that you find when you Google deploying on a Friday. Don't. I'm going to replace my clicker real quickly. So bear with me for a little bit. So just consider that didn't happen. We'll edit that in post. Yeah. So I don't know who you are, but if you deploy on a Friday, I will find you and I will kill you. Deploy on Friday at 5 p.m. Sure, that will definitely go wrong, right? We all know what happened before, and please, oh my God, just don't. And like any good meme, there is always a grain of truth. These memes don't pop up on their own. But basically all these memes say one thing. Don't deploy on Fridays. But where is this coming from? Where did these memes come from? Why are people telling themselves don't deploy on a Friday? So I'll get into a bunch of the reasons that I've identified over the years. The first of them is tradition. Simple. We've never deployed on a Friday, so why start now? This has always worked for us. So why stop doing what we were doing just because you're an external consultant and you think we should? No, this is what we've been doing as a company. We're still here, so apparently this worked. That's survivor bias speaking. That's tradition speaking. Yes, traditions have value and have merit. But some traditions are simply obsolete, and maybe we can change them. Tradition is one of them. Risk avoidance is another, and that's one of the more important reasons. I've been looking at companies in the Netherlands, and I'm sure that there are similar situations all over the world that do 1 or 2 releases per year. So every 6 months, every 12 months. And this is not an uncommon scenario in large enterprises. And the reason behind that is that things so often go wrong that instead of doing it more often, we actually pull back and we slow down. So we know that things are going to go wrong because our systems are not up to spec and we don't have a grip on things. Things are not well tested. So instead of actually doing it more, we reduce the tempo and we make 1 or 2 seriously big releases per year. And whenever people come to me and say, we do 2 releases a year, I say, no, you actually do 4 at least, because you do the official one, and then there's the oh shit bug fix release a week after that, right? No, that doesn't happen, of course. You have the 2 releases per year, and they are perfect. So this risk avoidance paradox is a thing that you see not just in larger enterprises, but in other companies and startups just as much. And it's a very interesting paradox. We associate a lot of risk with deployments in general, and deploying on a Friday in particular. So please stop doing it, because we need to manage that risk, and so please do it as infrequently as possible. Another is control. Business deciding when things need to be deployed or when they should not be deployed. Consider, for example, a broadcast company that doesn't want to deploy its software during the live broadcast of a popular TV show, for example. Because, well, if the thing goes down now, we lose all the SMS traffic and all the interaction with our audience, et cetera, et cetera. So here's the window that you cannot deploy in. And as the broadcast company becomes more popular and more popular, the number of windows in which we cannot deploy increases. And so there's actually control being put down towards the IT department or towards the teams that are running this thing from external sources. People that don't necessarily have a firm grip on what the application is all about, but instead they say, we've associated issues with your application before. Whenever we deploy that or whenever you deploy that, it fails. So please stop doing that during this and that time. And another thing associated with control is we can only go live at a certain date because of legal reasons, because of marketing reasons. We don't want this stuff to be in production before that date, so please stop. Control from the outside mostly. Confidence and trust is another big factor associated with not wanting to deploy on a Friday. Are we confident about our system? Probably not, because otherwise we would. We have enough confidence about our system that we know it's going to break, or most likely going to break when we do something on a Friday. We don't have a lot of trust, potentially, in ourselves, in our code, in our coworkers. There's not a lot of tests, probably, so if we change something in the code here, then something falls over there. You know, it's like you're digging in your front yard and something in your backyard falls over. That is something that happens in larger applications. And so we don't have a lot of confidence about our application, and we know that if we do something on a Friday, there's a good chance that it will break over the weekend. And if something happens on these large applications that we do not trust, then typically it takes a while for them to recover, for us to fix it. So this is the mean time between recovery, or the mean time to recover, actually. Whereas you see in a lot of enterprises, they are optimizing for the mean time between failures to be as high as possible. So the mean time between failures to be as high as possible, you deploy as infrequently as possible, because associated with a deployment is a problem, potentially. We always fail during a deployment, so if we want to fix that. So one of the things is also, if you have a system that is difficult to repair, if it breaks down, whether that's during a deployment or just randomly, then of course you will be hesitant to change anything, but especially on a Friday, because if your system takes 24 hours or more to fix, then you will definitely put it into the Saturday or the Sunday. So that's one of the other factors. On-call stress, or people being on call at all on a system of such issues. If you're not on call and you make the deployment on Friday and it breaks on a Saturday or a Sunday, you know that it's one of your coworkers that gets the call. And that will lead to a nasty conversation the next week. And that in turn will automatically, over time, lead to the team not trying to do that on a Friday, because they're mindful of, people's weekends, which is fair enough. I'm that way as well. But if that continues to happen on the weekend, then the team will automatically, okay, let's not do this on a Friday anymore, because apparently we cannot do that. So all these reasons together, a myriad of companies say, don't deploy on a Friday. Heck, I've even seen it as part of the actual rule book. Don't deploy on a Friday. Whether it's on a small application or a large application, we don't deploy on a Friday in this company. That's something we do not do. That's the rule you do not break. And the funny thing is, I used to say the same thing. I used to be like that. I used to be all about that. But let's reflect on what not deploying on a Friday actually means. I like my weekends and my evenings just as much as everybody else, right? So I don't want to be called in the weekend, in the evening, at night when things break. I really hate that. But if we cannot fix bugs, for example, bugs that pop up on a Thursday or a Friday, seriously critical bugs, can we deploy them? And if we can deploy them, why can we not deploy other things? What about 3 p.m. on a Friday? Is that okay if 5 p.m. is not okay? What about Thursday? If your deployment window or your repair window is 48 hours, then if you deploy something on a Thursday that breaks, you're fixing on a Friday, you're potentially also fixing on Saturday, right? So let's make a blanket statement then, let's not deploy on Thursday either, if our system is so rotten. So then we're left with Monday, Tuesday, and Wednesday. Okay. Friday, though, is 20% of the week. And that's a significant loss in mobility and agility and releasing of code that potentially your competitor is able to do. And you're losing 20% of the week in terms of flexibility. So I think as an industry, we can improve there. And it's not that, well, it is not easy, but it's doable. It's definitely doable. So one of the things that you would hear other people say, and me as well, if it hurts, do it more often. Now, this doesn't go for, physical ailments. So if you hit your knee against the wall, and you go to the doctor and you say, my knee hurts. Okay, why? Well, I banged it against the wall. Stop doing that. The doctor's not going to say, do it more often so it hurts less. However, in IT, this definitely, and especially in deployments and releases, this definitely goes. Because people associate failure, or people think negatively about failure, which is fair enough, but failure is not the opposite of success. As a matter of fact, Winston Churchill also said, success consists of going from failure to failure without loss of enthusiasm. So just keep on going. And if we release very infrequently, well, one thing is, big steps fail big. That's the only way that can happen. If you have a release per year, that's going to fail massively and very interestingly. And if you have small steps, then they fail small. You might still have the failure, but it will be a far smaller failure, and it will be far easier to fix and deal with, rather than the one giant release per year, which is compounded of all sorts of changes that you got over the year. Small steps fail small. And the interesting thing about this is that small steps and doing it more often reduce risk massively. I found this a couple of months ago on Twitter, and this graph to me describes the relationship between risk and realizing value, deploying work very, very succinctly. So on the left, we have an infrequent release schedule. So what you see is that as we do work, assuming we have a fixed amount of developers or ops people or a team, the team is there. The team gets paid regardless of what they do, right? They are just they're there. So the cost accrues linearly over time if we only consider their development cost. And as we go over time, we build up things, and we don't actually release that yet. And that is compounded, or that is translated into risk. Because the moment we actually deploy, this is where the green line shoots up, that's when we actually can validate the thing that we built against our customers. And that's when we see whether it's working or not. And then we start building again. We build up the pool of risk again, and then we deploy again. And so this part of the graph is actually when you realize value towards your customers. So while you are building things and you're not actually deploying them, you're not realizing value. You're just building up inventory. That's what that is. And as soon as you release that product into the wild, you deploy it to production and make it available for your customers, then you realize the value. But only then. Because only then they can enjoy your product. So on the right of the picture is a frequent or more frequent release schedule. So we still build up little pieces of risk, but we deploy very often to production. We realize that value very often, which means that the risk that we can build up is considerably smaller. And so that if we find out that something fails when we deploy, and failure does not have to only be technical, it can also be a failure of us. We write something, we build something that we think is useful, and actually we find out later on that nobody thinks it's useful, that nobody uses it. That's a different type of failure. And that's risk we take, but if we deploy far more frequently, the risk is quite reduced. So what all this leads to is the continuous everything mindset. Rather than doing things in phases, so we do specification, we do development, we do testing, we do hardening, and then we do deploy to production. We do everything continuously in a cycle that keeps rolling and rolling. It also means that if we can, we should let go of the project mindset and go towards a product mindset. Project mindset means we have a project that we do, a start date and end date. We form a team for the project. We do the thing. We build up knowledge, and then at the end we produce things. And then that gets shelved somewhere or deployed into production, hopefully. And then the team disbands because the project is finished. Whereas if you talk about products, then you start talking about life cycles. You start talking about small steps and iterations. You start talking about improving your product based on feedback. Continuous everything starts with continuous integration. Continuous integration is a term that is a little bit older already. It was coined by Martin Fowler years ago. And what continuous integration says is that we as a developer, we work on our machine and we build code. And then at some point we check that code into a version control system, GitHub or Mercurial, what have you. And when we do that, a process on a server starts running. And it checks out the code that we just committed, it builds it, and then runs some tests. And whether, depending on the language that you are in, you may actually use a compiler, or it may be something else that you use to build your software and then test it. And then when all the tests are green, you have an artifact that is validated and that you can do something with. But that's where CI stops. CI merely validates the artifact, or it lets you see that some tests have failed. Continuous integration specifies that we should integrate at least daily with the work of our coworkers. And what that means is this is a push system. So we push our work to the main line of development where everybody else is working, rather than pulling the work of everybody else to us, because that's not really integration. Integration is only when we push our work to the rest of the team and then verify whether our work integrates correctly with the work of everybody else, at least daily. And we'll come back to that because that has some consequences to the way we do work. Continuous delivery is another very important part of continuous everything. It may be one of the biggest things. Continuous delivery takes the artifact that we built on the CI server and automatically deploys this to an environment. We call this acceptance for now. We can also call it staging or something else, but at least it deploys it automatically to some environment. The environment should be as close as possible to production. And then note the red arrow between acceptance and production. What that means is continuous delivery says that we automatically deploy to an environment that is not production, and when we validate that build and we think, okay, this is good, this can go to production, then we actually push a button somewhere. It may even be a physical button. I've seen this in companies. And when that happens, or when that button is clicked or pressed, a deployment to production occurs. And the deployment to production should be automated as much as possible, but the actual trigger of the deployment, that is still human involvement. Now there's one important aspect to continuous delivery, and that says that code should always be in a releasable state. Code, your application, the product should always be in a releasable state. What does that mean? That if we have something, our product is in state X, and we say, okay, we need to push this to production now, then that should be able to happen. If we then have to have a series of exercises such as manual QA steps and UAT and hardening and other stuff, then our code is not really releasable at any stage, right? So continuous delivery says that your product, your application should always be in a releasable state. And when we build on to continuous deployment, that is actually taking the pipeline we saw in continuous delivery, but instead of having a human deciding when this is deployed to production, we automatically verify our artifact in acceptance. And when all the verifications have completed and everything is green, we automatically deploy to production and immediately deploy to production. And that means that we can deliver value to users safely and quickly, both very important, and in a sustainable way. We can keep doing this forever. And why would we do this? Well, if you look at, for example, the State of DevOps report, but also the Accelerate book that came out earlier this year, what they found out in research is that if you look at high-performing teams compared to lower-performing teams, on average, they deploy almost 50 times more than the high-performing teams versus the low-performing teams. And what's interesting is, especially their mean time to recover, so the time it takes them to fix their system when something breaks, is almost 100 times faster. So all of a sudden you go from days to hours or maybe even minutes to fix things. And that's a very, very important distinction here. But hand in hand with that, their change failure rate, which means the amount or the ratio of deployments or releases that actually go wrong, that fail, that have an error, is 5 times lower, 1/5 as likely as a low-performing team. So this data definitely shows that deploying more often will help you with quality and resilience as well. So safely and quickly deploying that software. A key part of the whole continuous delivery, continuous deployment mindset, but also DevOps, by the way, is automation. And automation and automation. I always like to say I try to automate myself out of a job in this context. It hasn't happened yet, but I keep trying. But automation is a key part here. Automation, automate everything that you can and should automate. Not everything necessarily. There are things that if you do them so infrequently that it's not worth the effort to automate. But automation leaves you a lot of time to focus on other things. Now you already saw this slide. Our code is old. We cannot do all this magical continuous delivery stuff on and automated deployments into production on our system because simply it's old. It's barely got any tests, if it's got any tests at all. It's impossible to change. If we change a rule here, then something breaks there, or if I change a line there, then 1,000 tests there fail. It's very brittle, impossible to change, and we actually do not dare changing it. So let's take a look at a few patterns that we can apply to deal with legacy. Now, legacy is often misconstrued as being negative, and yes, there can be some negative associations with legacy systems. However, typically legacy systems are earning money. So there is at least a positive part to legacy systems. Maybe that's the only, well, no. Anyway, dealing with legacy. So one of the important patterns here to use, and this works typically in online situations, is the strangler pattern. The strangler pattern says that let's take a typical monolithic application to start. The monolithic application is connected to the internet at the top and a database in the bottom. So far so good, right? Now what we want to do is we want to get rid or at least reduce the monolith in size, because monolith is not necessarily a bad thing, but there are a lot of monoliths that probably could do with a little bit of trimming. So what we can do is add a service, not necessarily a microservice, just a service. I'll leave the microservice discussion to somebody else. But what we do is insert a proxy between the internet and the monolithic application. And initially the proxy doesn't do anything. It just takes the traffic from the internet and forwards it to the monolith. So it's basically, a transparent proxy. Then we add a service which implements a small piece of functionality. Maybe it has its own database, maybe not. Depends on the service. And then we add a rule to the proxy that if, for example, you go to page A, it is handled by the service, and all the other pages are handled by the monolithic application. And then we add more services and more services that have their own data storage and search engines and what have you. And all of a sudden, we see that there's a bunch of rules in the proxy, and hopefully we'll end up with a situation where a monolith is either reduced to the size of all the other services, or it's completely reduced and it can be thrown away. This is the strangler pattern. The strangler pattern comes from nature, where you see a tree, I think it's in the mangrove forest, that grows on another tree and basically uses that as its host, and then wraps itself around the host tree until the host tree can no longer sustain its own life and dies. It's morbid, but that's what we're trying to do with a legacy monolithic application. So there you go. That's strangler pattern. Another one, and this is applicable to basically any system, not whether that's a desktop application or an online application, doesn't really matter. Branching by abstraction. Now, the word branch here doesn't have anything to do with the branches you associate with your Git, your Subversion. But this is a branch in functionality, if you will. So let's consider this setup. We have a module in our code that a bunch of clients in the code are linked to. And what we know is that if we want to change something in the module, then all of a sudden all these clients fall over, right? Because they expect the system to be in a certain state. They want to connect with that. Probably there are not a lot of tests there. It's brittle, and if we change something there, then a lot of things fail. And that's difficult if we want to change something in this old module. There's too many dependencies. What you can do is add an abstraction layer. And this can be as simple as an interface, if you look at a Java program, for example. But conceptually, this is like a facade that you put in front of your ugly building, and all of a sudden the building from the outside looks beautiful, right? But behind it is still this ugly office building. And what we do now is, in turn, we switch all those clients over to the abstraction layer. Now, the abstraction layer is a stable, defined interface. And because it's new, we can test this, right? We can do all the TDD on it that we want. And then at some point, the old module is not actually directly invoked or called on from any of the clients. They are connected to the abstraction layer. So what we can then do is actually start building a new module, a new office building behind the facade. And we can, depending on how we do that, we can either retain an abstraction layer in front of the new module, or we can make sure that the new module actually implements that stable interface, exposes the same stable interface that we specified here. And then we do the same trick again. we swap all the clients from the old module or the abstraction layer in front of the old module to the new. And hey, look at that. The old module is now unused, and we can get rid of this. And now we retain the abstraction layer, we retain the stable interface, because that could prove useful in the future, but we have replaced it with a new module that is hopefully completely under test. And this helps us to actually get rid of old code that is very difficult to change. Way you can also look at this is the expand contract pattern, where for a time you will add more code, you will cause intentional duplication if necessary, and then when you switch over to the new thing, you contract again and you reduce by deleting the old code. So this is those two patterns are very useful in dealing with legacy applications that are difficult to test and maintain. So let's take a look on branches, and now I'm referring to branches in your version control system, so your Git, your Subversion. Who here has ever had a merge conflict? Come on, be honest. Okay. This is one I copied from a client last year. And this is relatively benign. I think this pull request only existed for 5 days, and we saw pull requests in that project that existed for 2 or 3 weeks. Even. This stuff can happen. But what's really the problem with merge conflicts as well, or with branches, is that you delay integration. Remember when I said continuous integration, we need to integrate with the rest at least daily. What we're doing if we have long-lived branches, we're actually working solo on a thing that we do not integrate with whatever the rest is doing. And yes, if you're looking at Git, you can pull in, you can merge master to your branch, but you're still not integrating with what everybody else is doing. And yes, you can merge in every single branch that is out there from all your coworkers, but that will give you half a day of merging stuff into your branch, and you're not actually doing work. And you're still not integrating your stuff with the rest, because you're still pulling, you're not pushing. So we're delaying integration with long-lived branches. So let's take a look at a few branching strategies that you can apply here to deal with that. And I've blatantly copied this from Dave Farley. The first strategy is don't. And the second strategy is don't branch. And also the third strategy is don't branch. Now typically when I say this, and you're kind of cool about it, this can happen. I'm not necessarily hoisted up and walked out of the building by security, but I've had some talks where people look at me like, sure, and sometimes downright hostile. And what's the interesting thing about branches is, who here has used Subversion before merge info? I saw a hand like almost, okay. CVS, any CVS users? Cool. Do you remember how insanely difficult and dangerous it was to branch in CVS and Subversion? Yes. And so then Git came along, and branches were all of a sudden very easy and very cheap. And all of a sudden the thing that we've done years and years and years, which is not branch and have one single line of development, all that changed around, and all of a sudden Git flow started appearing and more interesting concepts. I'm not necessarily blaming Git for this, but then maybe I am. Trunk-based development is, as the name implies, because trunk is not part of the vocabulary at this point, because Git is referring to it as master, for example. But trunk-based development is not new. As a matter of fact, it's quite old. It's part of the extreme programming paradigm, which at this point I think is 18 or 19 years old. And even though cosmically it's very young, but we've already forgotten about this. Trunk-based development. Trunk-based development basically means that we have one single main line of development. We have one single, branch. There's not really a branch because it's just one thing. It's one street and one street only. Now, when I talk to people about trunk-based development, people that are used to using feature branches, they ask, but what about short-lived feature branches? And then, okay, my question would be, what is short-lived? What is short-lived for you? 2 or 3 days. Okay, anybody has another? 1 sprint maximum. Okay, and your sprint is? 2 weeks. So 2 or 3 days, 2 weeks. Is that short-lived? 3 hours. Bingo. Short-lived, if we look at continuous integration, which again specifies that we integrate with the mainline at least daily, means that the short-lived feature branch can never be older than how many working hours in a day? 8. If we start our branch when we get into the office and we merge it at the end of the working day, then that's the limit that we can do if we want to satisfy CI. So typically you would see short-lived feature branches in indeed the 2, 3, 4 hour mark. And then my question is that then still useful? Anyway, that's another discussion. Pull requests are also branches on their own. Who here uses pull requests for code reviews, for example? Okay, that's about half the audience. Well, let me first start by saying that code reviews are useful. Research has shown this, and that's kind of an open door, I think. But code reviews are useful. So if you did not have code reviews before and you've now switched to using pull requests for code reviews, that's better than the situation you were in. However, there's one inherent problem with code reviews in that way, and that is they induce flow delay. And let me explain what I mean with that. Imagine you're a developer, you're working on your feature, and you're done. At least you think you are. You submit a pull request, then you start doing other work. Okay? You switch your context. Now, the pull request ends up with somebody. Depending on the rules that you all agree on as a team, that may be immediately, and that may mean yanking somebody else out of their context, out of what they were doing. So they now have to switch context from whatever they were doing to, okay, what is this guy intending with this pull request? What was his idea or her idea behind the pull request? Why did they submit this? And then they start reviewing, and there may be a few changes suggested, and it goes back to the original author, who has moved on and is doing something else. So they have to switch back again, right? And this induces delay quite significantly. Depending on the rules that you agree on, if you say, okay, if a pull request comes in, somebody needs to jump on it within 5 minutes, then you limit the flow delay a little bit, but typically that's not the case. One thing that's also interesting with pull requests is that you will see people delaying themselves if they get a large pull request. Like this pull request affects 1,500 files. Ooh, I need to get some coffee first before I start diving into that. Or, this is too big. I cannot review this. And research has shown that if your pull request becomes too large in, for example, number of lines affected, then people will stop looking at it seriously and they will start scanning. And they will start scanning like they scan the headlines in the newspaper. They don't really read, right? So I don't see any obvious errors. Looks good to me. And that reduces quality. So is there a better way? Yes, of course, otherwise I wouldn't begin about this. And that is pair programming. Maybe not like this. Because I'm sure you see that the guy there on the left is not really seeing what the guy on the right is doing. However, pair programming is a definitely good setup, a definitely useful setup. What you need to be aware of, though, is it tends to tire people. Working together for long periods of time, very intensely, very focused, tends to wear out people. So frequent rotation. Rotating the person behind the keyboard and the person actually sitting next to that, the navigator and the driver concept. And also frequent breaks, and maybe not do it all day. That depends on, again, the team, the persons you're working with, their experience with pair programming. But what does pair programming give you? Continuous and inline code review. You're talking to each other about the code you're writing. And what is interesting, in a pull request, you cannot see why the code is there. You cannot get into somebody's head, right? You only see the result. And what you can definitely not see is why the code that was not written was not written. And that is something that you cannot see in a pull request. This is something that you can see happening during pair programming, because you can discuss about this. What it also gives you is knowledge transfer from a more seasoned developer to a fresh developer, a new developer just out of school. It also helps knowledge transfer from, for example, somebody with more an ops background to somebody with more of a dev background. And it gives you, if your industry is so inclined, it gives you 4-eye principle. They're continuously 2 sets of eyes looking at that piece of code. Another option, and you see this appearing more and more, is mob programming, where instead of taking a pair, so 2 persons, you essentially cram the whole team behind a big screen, and there's a laptop or at least a keyboard, and then basically the whole team is going to work on something together. Somebody's doing the typing, and the other people are essentially shouting commands at him, like type this, type that. Now, there's a little bit more structure to it, of course. Otherwise, the person behind the keyboard would go absolutely crazy. However, I read an article or a series of articles about, I think, a team in Sweden that has started out from day one of the team forming doing this, and only doing this. So every day is a mob programming session. Company above you. Cool. It's a broadcast company, right? Is that? Okay. Anyway, there is a series of articles about that online, and yes, there are things that they encounter. Nothing is ever perfect, but what this gives them is it frees you from having separate design discussions and all the other things, because that happens organically during a mob programming session. And the mob programming session doesn't always have to be behind a laptop. You can also work together behind a whiteboard and sketch things out. And you have another comment? Or? Sorry? Okay. That's all right. Again, like pair programming, this is intense and it wears people out. So you need to allow for people rotating in and out of the mob programming sessions. Sometimes people have, individual meetings that they need to go to, or deal with things at home, stuff like that. But it's a definite interesting setup and useful as well. Now, feature branches are also used to distinguish features, or actually organize them in time. So we have a feature ready, and we want it to go to production at a certain date, so we will merge at that day and then deploy. So that's actually abusing feature branches for something where there's a better option. And the better option is that we actually should decouple the deployment from the release. The deployment is a technical exercise and should always be possible, whereas the release is a joint decision with the business, that we actually put something or make something available for the customer. And how can we do that? Well, feature toggles is the concept that helps there. You can, some people refer to that as feature switches, feature knobs, feature flags. You heard as well. Feature toggles, all the same concept. And the feature toggle allows you to switch on or off at runtime, preferably, certain pieces of your application for certain groups of customers. And this is something that, the Netflixes of this world are doing at an insane scale, but something that definitely applies for smaller projects as well. And what does that allow you to do? Well, take a look at this picture. There's 2 versions of a search page for a product that I've worked on a few years ago. The left side is the old version, and the right side is the new version. Now, what's interesting here is that the left side is served by an older stack, an older technology stack that contained, for example, Solar and some other stuff. And on the right side, we migrated to Elasticsearch, amongst other things. And we did a complete design overhaul. Now, this thing is not something you build in a day, right? So it does not, it's not a few commits. So what would have happened if we had halted deployments, or if we had built all this on a feature branch? This took us about a month to build successfully. So we would have a feature branch, at least, that would have lasted for a month, or we would have halted deployments for a month. That was not acceptable because there were other things going on. So instead, we put this thing behind a feature flag. And the feature flag is essentially a glorified if statement. So if the condition evaluates to false, we show this. If it evaluates to true, we show that. And so what we did is we built the new version of the search page, all the new infra, etc., over time in many small changes. And then at some point we were like, okay, this is good enough to release to our internal network, our own company's network. And so people from inside of the network that accessed the site saw the right side of the picture. And then we started getting early feedback, very useful. And then at some point we were like, okay, we think this is good enough. And we enabled the feature flag to 10% of web traffic. And then we started looking at metrics. Now we wanted to get rid of the old thing. So what we said is that if our metrics are at least as good as the old thing, then we consider it good enough. And at 10%, we were actually way better than the old thing. So we ramped up to 50%, still way better, and then to 100%. And then we could start removing the old version of the page. And we continued doing other deployments during that whole period as well. You know, changing things on other pages, changing infrastructure, etc. There is one thing you need to be aware of though, and that is feature toggle debt. Don't introduce feature toggles everywhere just because you can, or you heard that's a good idea, because then you will end up with a bunch of feature toggles that together will lead to a combinatorial explosion of possible paths through your code. So what we ended up doing was, in every story that we pick up that we feel needs a feature flag or feature toggle, be very critical about whether you need that or not, but if you decide that you need that, also build in a schedule that you actually get rid of the thing when you've set it to 100%. Or if you foresee that you're not going to 100%, okay, then roll everything back and delete everything, because that's that in total. So keep in mind, now some feature toggles, but that's a discussion for another time, will remain long-lived, and then they become sort of ops toggles or marketing toggles, but that's another discussion. Now, you've seen me, or you heard me say the word pipeline at least once, and the pipeline in continuous delivery is a key thing to actually producing things and deploying them to production. So a typical version of a pipeline, not the, but a, is where we start checking out code. And this happens on a build server. It could be a Jenkins or Travis or Circle, or there's a whole bunch of different competitors out there that essentially do the same thing, but then with different colors. And then you compile, and then you test, and then what you end up with is a package of your code. Depending on the language you're in, it may, for example, if you do Java, it may be a jar. If you do something else, it may be another package format. That package is uploaded to an artifact setup somewhere, and then the artifact is deployed to acceptance, at which point we verify it there. And if that's all okay, and again, these are automatic verifications, these are automated tests, we deploy to production, where we again verify that everything is still working. The pipeline as code movement is something that started a few years ago with Jenkins, but also Travis has been doing that, and Circle and GitLab CI at this point, where instead of clicking a pipeline together, we actually write that as a script, which hopefully can be tested as well. Hello, Inception. And then you actually write your pipeline as a piece of code. At this point, you've probably in other talks heard about infrastructure as code and more things. As anything as code. So it can be put into version control, it can be tested, it can be validated, it can be rolled out automatically. The pipeline helps us with continuous testing, and there's that continuous again. Continuous testing, and again, this is a look on things, not the. You can think of various potential testing layers to help you get confidence, enough confidence in your code, in your application. We start with typically unit tests, small tests that directly test individual classes and objects that run very fast, that are very easy to maintain and to write. We do integration tests where we actually verify components, we verify the interactions between components, between systems, maybe even contract tests between different API layers, for example. Funny thing about a contract test, I've read a very nice explanation about that. Who here has a smoke alarm in their house? Okay. Who's ever burned down their house to test the smoke alarm? None. Cool. That's a contract test. So we test once a year, twice a year by pressing that button on the smoke alarm, and then you'll have that very annoying, very loud noise, hopefully, and then you know that the smoke alarm still works. Or at least that's the contract between you and the smoke alarm. We don't actually have to burn our house down to test the smoke alarm. And unfortunately, this is what we end up doing a lot in software. We try to burn the house down to test the smoke alarm. Anyway, integration tests, acceptance tests, where we write, for example, in the given when then gherkin setup, we write in plain English or German or Dutch what our system is supposed to do, what we think our application is supposed to do, and how. And then at the end, end-to-end tests, which by their very definition are brittle, difficult to maintain, usually run through Selenium or Cypress or other browser simulators. And they are brittle because typically we write them as like click on the button that is marked as IDX or that has color blue, and then we change the color of the button, and then all of a sudden the end-to-end test fails, even though the functionality of the site has not changed. The functionality of the site is the same, but the test still fails because we changed the ID or the color of the button. So they are very fragile. Now, turning this all around, you end up with the testing pyramid. And the testing pyramid is all about maintainability and speed of your tests. So at the bottom, you have the unit tests. As you go up in the pyramid, cost increases, and as you go down, speed increases. So at the bottom, the unit tests are the fastest and the cheapest. And then as we go up, we see that end-to-end tests are the most expensive and slowest to run. They require an actual system running, and they require a fake browser or an actual browser. So that's all kind of set up, and they are hard to maintain. They are difficult to maintain. Important part of testing that we should not forget about are exploratory testing and user feedback. So a user feedback loop through, a feedback form somewhere, like this stuff has broken, please fix it. But also exploratory testing, where our QA people will actually go through the site on production and verify that the thing is still working as we expect. And or find out parts of the code that maybe we should bring under test a little bit better. And on the right, monitoring and alerting. Not everything shows up in tests. We cannot test everything. Some things only show up over time, under load, under stress at certain points in the day. So our alerting system helps us. And believe it or not, they are part of our testing setup as well. But good enough is good enough. Don't try to test everything. Nothing is ever watertight, just ask the Titanic. But with testing, it's easy to overdo it. And then you end up with a pipeline that takes way too long. No test suite detects every issue. We only detect what we know as being issues. We can never detect the unknown because we simply have not, that's limited by our own imagination, right? So we only detect so much. And pipeline speed is key. If we have pipelines that run, I've seen pipelines that run for more than a day, and that is very detrimental to productivity and also to developer health, I would say. So my personal view on pipeline speed is that I'd like my pipelines to deploy stuff into production within 15, 20 minutes tops. That gives a reasonable feedback loop where if I deliver something that actually ends up breaking production, that I know it soonish. I try to limit it as more than that, but at least if the testing stage fails, I want to know about that within the next few minutes, for example. So have unit tests that run in a few minutes time, not hours. And, parallelize as much as possible, stuff like that, but pipeline speed is key. Now, moving on to deployments, the final part of this whole thing, and I'll talk you through two different deployment strategies that you can apply here that help you in a continuous delivery context. The first one is the CANARY deployment. And the CANARY deployment gets its name from miners back in the day that took a canary or another type of bird into the mine, and when the canary dies, or hopefully it makes noise before it dies, there's gas in the mine, right? It's something that we humans could not detect, so we needed another thing, a canary. And the canary in IT or in the deployment scenarios is much like that. What the canary means is, well, let's consider a standard scenario where we have a load balancer between the internet and our application, and we have a service or an application of a version 1 deployed behind that load balancer, happily serving traffic. And then what we do is we deploy version 1.1 of the application, and we hook that behind the load balancer, but we don't give it any traffic yet. And then we ramp up the traffic just a tiny bit, 1% maybe, and this depends on your context. For example, if you are Amazon and you do 1%, that's a lot of traffic, so that may be too much. But for us mere mortals, then 1% is probably a good point to start. And our 1% of traffic gives us information. Is this new version working correctly? Do we see elevated numbers of exceptions or errors or other things going on, or complaints from users, what have you? And if there's nothing, then we ramp up slowly but surely to 100%. And at that point, the old version of the application is no longer serving traffic. So now it can be removed from the load balancer and deleted. So that's the canary deployment. The rolling update is, as the name says, we update things one by one in a rolling fashion. And again, we have a load balancer with the 1.0 version of our application behind it. And then when we want to roll out version 1.1, we start it initially, we let it boot, and then we replace the one copy of the 1.0 version of the application with a copy of the 1.1 version. Now at this point, you'll have two copies, two replicas of the old version and one of the new version. And then we update those one by one until we have everything replaced with the new version. Now typically, if things were to go wrong, it would be either here while the service 1.1 is booting, or when it's just receiving traffic. And we can easily roll that back by replacing it with the 1.0 version again. But let's assume everything works out well, and we replace all the instances of the 1.0 version with the 1.1, the rolling update. Now turning that all into a pipeline, and then pipeline as code, and then displaying that, feedback, the visual feedback is a very important part. This is an actual screenshot from a Jenkins pipeline, a production pipeline that I was working on 6 or 7 months ago on a project, which at that point took about 25 minutes to deploy to production, and we have since reduced that to 12 minutes for a typical run. So that's a 50% improvement, almost. And you can see here in the stages, we have testing, we have publishing of artifacts, we have deployment to acceptance and test, and then deployment to production in a single pipeline. Now, visual feedback is important, but there's another sort of feedback that I want to share with you. And on one of the projects that I was on, we used this. This is an LED lamp or a siren. And whenever the build broke, we would fire this thing, combined with some noise that would echo through the office. It would alert everybody that things were breaking, which is a key thing. And you don't necessarily have to have a siren like that, but you need to be you need to make people aware that the pipeline broke. Because if we try to do everything through the pipeline, then the pipeline is our backbone of our application, of our deployment of our application. So if the pipeline breaks, it's very important to quickly fix it. Because if we have to do an emergency fix to production and our pipeline is down, that's a bit of a problem. So pipeline breakage is a key thing. Interesting anecdote, at some point we replaced the sound for the siren with the foghorn of a ship. Now, and the problem is, the project this was on was near a large river where cruise ships came through the river. So at some point the foghorn went off, everybody runs to the window looking at a ship that's not there because the build broke. And then the next day we had an actual ship coming along and people started looking at the code. So we quickly got rid of that particular piece of audio. But it's important to have feedback. So, closing off, this whole topic was about deployment on a Friday, even though this is a Wednesday. And I hope to have given you enough info and suggestions and ideas that you can do it too. And like Borat says, you can do it too on Friday. There's some literature that I want to leave you with. The book by Jez Humble and Dave Farley, or I should rather say the Bible, the CD Bible. Then there's Accelerate by Nicole Forsgren and Jez Humble and Gene Kim. And Steve Smith has written an interesting book about measuring how your CD adoption is going. Metrics that you can use to see where you are lacking in that transition. And if you want to have more arguments against branches and some in favor of, then please go to trunkbaseddevelopment.com for your reading pleasure. I'm reachable again on Twitter here. That's my email address and my blog as well for rambles about this and other topics. And I thank you so much. Have a great lunch.